Let's understand some more thing about forbidden gap, or this is called as energy gap simply. This is represented by delta E. This is the amount of energy between valence band and conduction band. So we can write it as delta Eg equals to conduction band minimum minus valence band maximum energy. No electron is present inside this forbidden gap. Width of forbidden energy gap depends upon the nature of substance. As temperature increases, this forbidden gap decreases slightly. So conductors does not have this forbidden gap. In semiconductor, this forbidden gap is very small. So electron can gain some energy and move to valence band. In insulator, this energy gap is very high. So electron does not gain that much amount of energy so that it can move to valence band. In conductor, there is no forbidden gap as valence band and conduction band are overlapped. In semiconductor, this band is quite small. And in insulator, this band is very large. So electron cannot gain that much amount of energy so that it can jump from valence band to conduction band. In semiconductor, it is easy for electron to jump from valence band to conduction band. Now, referring this, let's understand semiconductor. Semiconductors are mainly of two types. First is intrinsic semiconductor. Second is extrinsic semiconductor. Intrinsic semiconductors, I personally call it as pure semiconductor. And extrinsic semiconductor are also referred as impure semiconductor. So why these are called pure and why these are called impure, let's understand. Intrinsic semiconductors are the semiconductors which are already present in the nature. And then we add some impurity into intrinsic semiconductor. And those impurity is called as dope pair. In intrinsic semiconductor, we add some impurity and it becomes extrinsic semiconductor. This impurity is called as dopant. And this process of adding impurity will be called as doping. So we add some dopant inside intrinsic semiconductor and after doping, it becomes extrinsic semiconductor. As we can see, all the conductors have 1, 2 or 3 electrons in their outermost orbit. And all semiconductors have 4 electrons in outermost orbit. Example, carbon, example, silicon, example, germanium. Now let's start with the question. The very first question is, a figure shows a DC voltage regulator circuit with the Zener diode of breakdown voltage 6 volt. If unregulated input voltage varies between 10 volt to 16 volt, then what is the maximum Zener current? Option A, 2.5 milliampere. Option B, 1.5 milliampere. Option C, 7.5 milliampere. And option D, 3.5 milliampere. Now, in this question, we are given with the circuit where Zener diode is connected in series with RS resistor. Also, load resistor is connected in parallel to Zener diode. The characteristic of Zener diode, all we know is it maintains a constant voltage. So, voltage across Zener diode in this question is given as 6 volt. Yes, it is given here. Now, input voltage will be first 10 volt and then 16 volt. So, we'll be applying both the inputs and then we'll check what will be the current. Now, let's go ahead. So, once breakdown happens in the Zener diode, the voltage across load will always remain 6 volt as voltage across Zener diode is 6 volt and voltage in parallel always remains same. So, voltage across load will always remain 6 volt. Now, we know the value of load resistor which is 4 kilo ohm. We also know the voltage across it. So, we can easily find the current going through it which is IL. IL, V is equal to IR. I is equal to V by R. So, IL will be equal to voltage across it upon resistance. So, it becomes 6 volt upon 4000 ohm. Now, if we do this calculation, we get the value of current across load will be equal to 1.5 into 10 raised to minus 3 ampere. Now, let's go ahead. Let's find out the voltage across series resistor. Total voltage across series resistor will be equal to total voltage minus Zener voltage as both are connected in series. So both have total voltage which is V and voltage across Zener diode will be Vz and voltage across this series resistor will be Vs. So we can simply write V equals to Vs plus Vz and this equation then becomes Vs equals to V minus Vz. We know the value of total voltage which might be 16 or which might be 12. So let's take the maximum out of it. Voltage of Zener diode is taken as 6. So 16 minus 6 comes out to 10 volt. Now this 10 volt is a voltage across series resistor. We know the value of resistor. We know the value of voltage across it. We can easily also find current across series resistor. The current across series resistor will be equal to Is equals to Vs upon Rs. We know the value of Vs, which is 10. We know the value of Rs, which is 2K. So 2K is nothing but 2 into 10 raised to 3. If we do the calculation part, answer of current across series resistor comes out to be 5 into 10 raised to minus 3 ampere. Now, the current across Zener diode will be equal to, let's take the equation of current. Total current is flowing through Is, and then Is is getting divided into two parts. First is going across Zener diode and second is going across load resistor. So we can simply write this equation as Is equals to IL plus Iz. But what we want is Iz. Then Is minus IL will be equal to Iz. We know the value of Is. We just got it as 5 into 10 raised to minus 3. We know the value of IL. What we got is 1.5 into 10 raised to minus 3. If we take the difference, then value of Iz comes out to be 3.5 into 10 raised to minus 3 ampere. This is the option D. So option D is the correct answer.